36,000. Some of you had that written down. Maybe you weren't done whenever I came by. But in first period, I had somebody say 36,000 guppies. Would that make sense? Like, I'm pretty sure you couldn't even fit 36,000 guppies in this fish tank, even if it didn't have any water in it. So that would not be a good answer, right? It's part of the process, but it's not the answer. Okay? What did you do after that, Demetrius? Okay, so you're basically, like, if you got 36,000, I should have put right here, this is cubic centimeters. That is going to be 36 liters, right? And you may not have done it this way. There's some other approaches that you can take. Then if you got 36 liters, what do you need to do to figure out the number of guppies that you can have? Divide that by 5, so 36 liters divided by the 5 liters it takes for each guppy is going to give you 7.2, but you can't have 0.2 of a guppy, so you just have to round to 7 guppies. Okay? Could you put 10 in here? Probably, but they might not be quite as happy, right? They might be a little too much. You definitely wouldn't want to put 20 in there. Your fish tank would be nasty in no time. So, yeah, might not be good. It would not be best for the health of the fish. Now, probably for a household aquarium, you may or may not be the most concerned. Now, some people have those like big, expensive aquariums with those like big, fancy, expensive fish. If you paid a bunch of money for a fish, you would probably care a whole lot more about making sure that it was well taken care of. If you were like our family and you have a betta fish in a little box of a thing and you're just wondering how this thing is still alive, you probably didn't do much figuring on this. But yeah, you can only have one betta fish. You can't put 2 betta fish together because then you'll have 0 betta fish. Or I guess maybe just the strongest betta fish left. So let's keep going. Okay, now, here is something we're going to see quite a bit of. It's sort of a backwards problem. Okay? It says, find the diameter to the nearest unit of a cone with an approximate volume of 22 cubic feet and a height of 21 feet. Okay? So, first thing is we got to have our note cards. Everybody's got a note card, right? They have not lost their note card. Check on your neighbors, see if they got a decent looking note card. Need a note card. All right, so got that note card. Which formula do we need? Cone. We need cone. And so volume of a cone, you had 2 options on that. It was 1/3 times 1/2 base. I'm sorry, not base. That's a pyramid. Ignore that. 1/2. No, not 1/2. Okay, sorry. I'm doing this from memory. This is why you need a note card. Your brain may fail you. 1/3 pi r squared times the height. Okay? All right, so the issue here is what information did they give us? They gave you volume and height. Okay? So you got volume and you've got height. So that 22 has to go over here. And that 21 has to go right here. So in our formula, we've got 22 equals 1/3 pi r squared times the height, which is 21. I really don't like this problem because of the answer. It's a little bit weird, but we'll keep going. The answer is a little bit weird. I need to change it, but I'm not going to now. Now, we need to solve this equation. What are we solving for? R. That's the only variable left because pi is not a variable. Pi is a symbol that represents one specific number, right? So, how in the world am I going to solve this? Guess and check will take you forever. Not if you want a very specific answer, depending on how much I make you round to. Now, if I don't make you be very specific, then you could guess and check it. All right, what do you think, Abby? Okay, what should I divide by? It looks complicated. You are right, we need to divide, but it looks complicated. What do we need to divide by? 1/3 pi and 21. So, we got to get rid of everything that is not R, right? Louie over here that does everything by hand is the only one that gave me the answer on that one. Let's say that perhaps we are not that good at solving equations. Okay? There is a way. I'm going to do this first only because I know that some of you out there need it. Okay? If I am terrible at solving equations, I could do f of x equals and g of x equals. This is not my preferred method. I want to do what Louie told me, and we're going to do it here in just a second. But if you're stuck, once you get an equation right here, pull up Desmos. Again, I'd rather you not. I'd rather you do it by hand, but I can live with it if you do this. So if I do f of x equals 22 and g of x equals 1/3 pi times, you got to use an x squared there instead of radius, times 21. Okay? Right now, I don't see much, but if I zoom out some, I can see right here, I've got two answers. What's this answer? 1 and -1. But does -1 make sense when we're talking about the length of a side of something? No. So we would throw out the negative answer on this because it wouldn't make any sense. So, we would get R equals +1. But I said I don't like this problem because really the answer is not exactly 1. It's a little bit off from 1. But depending on how much you had to round to, you're just going to get 1 in most cases. Now let's do this by hand because I also want you to see how to do that because it's really just a couple steps for that. So if I've got 22 equals 1/3 pi r squared times 21. All of this stuff right here is multiplied. It's 1/3 times pi times r squared times 21, right? So I can divide off everything but the r all at one time. So I can divide by 1/3 pi times 21. Get rid of all of them. So that'll cancel that, that, and that. As long as I do it to the other side. 1/3 pi and 21. Okay? So if I go over here to Desmos and, oh, I don't want that. If I go over here to Desmos and I do 22 divided by, probably going to need some parentheses here, 1/3 times pi times 21. I'm getting 1.0004. So that radius, oops, let's go back to blue, radius squared should equal 1.0004. And so on. That keeps on going. Keep that in your calculator. I'm not done. What do I have to do to get rid of that square? I would square root both sides. So R would equal, and when I go over here, I can square root. I'm just going to copy and paste that number, and I get 1.0002. Now, usually I ask you to round to 3 decimal places, so it would just be 1, and it would be okay with guess and check. I need to go change that number so you don't get 1 for this. I don't like that very much, but that would be our answer, and it would be feet. Okay? So you're going to see several of these backwards problems for this. Number 10 is another example of a backwards problem. I want you to try number 10 on your own. Okay, so try number 10 on your own. I'm going to freeze my screen. I'll work this out so you can't see. Try number 10 on your own. Give me your answer to 3 decimal places on this one. What is your formula for here? Pi r cubed, not squared, right? So, but you can't divide by so we got here. And what you've done so far is good. And then you got to solve it. You can either do it as much or by hand. Yeah, so you can always, anytime you have any equation for the variables, you can always just have the variable on the left side, you have it on the right side, and just do it across. Okay, so you can always do that. This is your fault. It goes right to the back. So it doesn't go on the end, it goes to the back. And it says, you bet you figure out what to do. Good. All right. So look at what formula we're using here. Okay, and so it tells us that that the volume is 342. So where do we plug that in now? Which letter stands for volume here? B. So we're going to put 342 there, and it will be equal to the 4/3 power cube. So it's pi r cubed. Right there, so 4/3 pi r cubed. Okay, pull up this nice form there. Yeah, cube root is, if you need a cube root, Okay, and we'll do g of x equals the right side. Instead of using r, you have to use x. So do type y, and it'll show up p. So yeah, and then do x to the third power instead of r, because it doesn't like. Okay, so what you're looking for is where those cross. Then way out. Okay. All right. Okay. Let's look at what we've got here. You should get 4.338. Did you guys get it? Okay. All right. So, whether you're doing it with Desmos or by hand, the first thing you've got to do is plug in a 342 right here for that V. If you do this with Desmos, then you will have f of x equals 342. G of x equals 4/3 pi times the radius cubed, but we're going to call it x cubed instead of radius because Desmos isn't going to like that r right there. Now, when you look at that, even if you full screen it, you got nothing. You can't see it. So you're going to have to zoom way out. But think about this number's 342, so you got to get like way up here. You can finally see it right here. And there's your point. I like to zoom in a little bit to make sure I'm getting the right point. But it is right there at 4.338. Okay. Some of these are a little hard to see on the graph. It's hard to find where they're at. So that's why I like for you to be able to do them by hand as well. For that, so if you're doing this by hand, you just got a 4/3 and a pi you've got to get rid of. So you divide by 4/3 and pi, which gives you 81.646 and so on. And then to get rid of a cube, you have to use a cube root. And so on Desmos, if you need to do a cube root, it is right down here at the very bottom. You put a little 3 right here. You got your 81.646. And it'll give you your answer there. Questions on that? Okay. Well, let's keep going. Okay. They love to give you problems like this that sort of combine some algebra and some geometry together. The only time you would use this real world scenario is if you were like optimizing something. If you were in that case, you would probably be in like an engineering position where you're designing something with certain specifications. So I'm not saying that you're going to use this if you're a landscaper trying to figure out how much mulch you need, but somebody somewhere in the world may use it. So rectangular prism is our easiest one, right? What is that volume formula for rectangular prism? Length times width times height, right? So for this, it tells us we have a length of x, so L equals x. A width of 2x plus 1, so W equals 2x plus 1. And a height of 10, so H equals 10. And we are supposed to write an expression that can be used to find the volume of the rectangular prism. Okay, so for the volume of that rectangular prism, we would have, instead of L, we would put X. Instead of W, we would put 2X plus 1. Instead of H, we would put 10. They will probably not leave the answer like this. What they'll probably do is like distribute here. Before I would distribute, I would put the 10 and the x together because all that stuff is multiplied. So you can rearrange it if you want. I would write it like this. 10x times 2x plus 1. And then what could I do with my 10x? I could distribute. So if I distribute here, my volume is going to equal 20x squared plus 10x. Now, this is all this asks you for. That's the answer. Let me give you just like a tiny preview of like where in the world something like this would be used. Perhaps these are the specifications you have for like some sort of box or some sort of packaging for something. You know that your box can't be any higher than 10 inches. And then for whatever reason, you know that you need x by 2x plus 1. So if I go graph this equation that I just got for volume, so volume equals 20x squared, what was it, plus 10x, and I hit the house button here. This is not the greatest real world problem because you perhaps maybe are looking for like the minimum volume that you could have. This is not a great real world problem because your minimum is a negative 1.25, which is not the case. You can't have negative volume, right? So I might should have graphed that before I was going to look at it. But let's pretend it had a plus 20 right here. And then if you wanted to know, oh, that's still not good. Let's pretend it looks like this. If you want to know like the minimum volume, like what would hold the least that you could have, it would be, you know, those would give you your minimum volume. So you might be looking for that for whatever reason. So that is sort of like, you would work in something where you're like designing this if that were the case. All right, let's look at 12. A cube-shaped bead has side lengths measuring 12 millimeters. Each bead has a circular hole in the middle. The diameter of the circular hole is 2 millimeters. Find the volume of the bead. So let's draw ourselves a picture for this to picture what's going on. We've got a cube here, and then it's got a hole that goes through the middle of it. Okay? So like you can think this goes back all the way through there. I don't know if that's the best drawing there, but that hole goes all the way through the cube. And for this, each side of that cube is 12 millimeters. And it tells us the diameter of the hole right there is 2 millimeters. Okay, so what we need the volume of the bead, but the cylinder in the middle is not part of our volume, right? It's just like it's empty space. So what should we do to figure out the volume of this bead? Okay, that'll give us the cube on the outside. So that's going to be part of it. Okay, we got to subtract or minus the cylinder in the middle, right? So we are going to find the volume of the cube, which is one of our easiest ones to find. It's just 12 times 12 times 12. And 12 to the third power is going to give us 1728. So the cube without a hole would be 1728 millimeters cubed. But then we need to find the volume of that cylinder in the middle, and we're going to subtract it out because it's not part of the volume. It's just open space. So V of the cylinder would be, volume for a cylinder is pi times the radius squared times the height. What is the radius of that cylinder? Oh, 2 or 1? It's 1, because 2 is your diameter, and it gets me to, like, I do these wrong sometimes. It is just 1. What is the height of the cylinder? It would be 12, because it's going to be this length right here on the side. Okay? So if we multiply that together, pi times 1 squared times 12 is going to give us 37.699 millimeters cubed. So to find the volume of these two, we got to do 1728 minus 37.699, and we are going to get 1690.301. Okay, questions? So if you have like a hole in something, you want to find the volume of the outside, subtract the volume of whatever's on the inside. Okay, that's our last one on these notes, right? Okay. All right, so, and I cut it parallel to the base. So horizontal karate chop. There. What shape would I get? Okay, it's going to be a circle, right? This will be a circle. Yes, Jacob. Oh, you're just stretching. Okay. Okay. Perpendicular to the base, that'll be a circle. What if I chop it vertically? Okay. Vertically, it's going to give me a rectangle. Sometimes kids have a hard time picturing that. And they say, like, think it'll be like an oval. So I've got my box of solids up here. So, like, one thing you can think about doing is think about, like, taking a marker and, like, cutting this way. These are kind of nice because they're see-through. So you can kind of see that shape, right? Think about tracing that on flat paper. That would be a rectangle there. So that helps sometimes. There. Okay, let's keep going. What time do we got here? 11. Okay, we're in good shape. All right. Okay. For 1, what is the vertical cross section going through the center of the figure shown? Vertical. So I got one here. And it's got to go through the center, so like through that top part right there. Oh, that green one does not show up on that. Use a black marker. Oh gosh, it's hard to write on. So if I cut it this way, there are 3 sides to that. It's going to be a triangle for that. So it would be A. What would the answer be if I cut it horizontally instead? Cut it like this way. I think it would be a square. Because I think that is meant to be a square base, although they didn't mark our sides all even, so that's probably why they didn't ask us that question. Because I think it's meant to be a square on the bottom, and it's just kind of tried to make it look 3D. But I could get the argument for trapezoid, because it kind of looks a little bit trapezoidy there on the bottom. Yeah, vertical is definitely going to be a triangle. Through the center. Now, what about vertical if it's not through the center? What if I karate chop it here on the side? Alright, watch this. If I cut it on the side, that means it'd be like cut here, and then like straight down, right there. And then across the bottom. What shape have I got there? Trapezoid. So, although I would have called it a rectangle if I hadn't actually like drawn it there. Let's look at 2. Daniel cut the corner off of a cube as shown in the diagram below. Points A, B, and C are the midpoints of the edges of the cube. What type of 3-dimensional figure has been cut off? So the cross section is definitely a triangle. We can see that. But what's been cut off? What part is missing? It's definitely not a cube. It's going to have something to do with a triangle. Is it C or D? It is D. It's pyramid. It's going to be pointy because you got a corner over here. So it's a pyramid. A prism has like two triangles on the side and rectangles all around. So it's going to be a pyramid for that. Okay, 3. You can think about the cone that's going around. A right circular cone is represented by the drawing below. Which figure could not be a cross-section for a right circular cone? It's going to be D. Right? It can't be a rectangle. You could cut it across to get a circle. You could cut it slanty to get an oval. You could cut it straight down the middle, like through the point, to get a triangle, but you're not going to be able to get a rectangle. There. Okay? Questions? All right, let's keep going. All right, now this next part. Oh, did I close? Shoot. I used to have a little thing in my closet over there that I used to help you visualize this, but over here, what three-dimensional figure do you get when you rotate a rectangle 360 degrees? So, a rectangle, let's say I have a piece of paper right here that is a rectangle, and I take it and I spin it 360 degrees. So if we imagine that that is making a solid of some sort, what solid would it make? What do you think, Jacob? It's going to be a cylinder, right? On the top here, this is going around in a circle. The sides are straight. So, not like that. That is like your lateral sides. It would be as wide as the piece of paper. And then you have a circle on top, like the diameter would be the top of the paper. I wish I could spin it really, really fast where it would almost look like it's 3D there, but can't. There, you can also think about like taking that rectangle I drew right here. If you spun that rectangle around and around and around, it'd always be inside of this cylinder, right? So that would be a cylinder for 4. Okay. Kathleen rotated an isosceles trapezoid 360 degrees around its longest base. Which choice could be the resulting solid? So first of all, let's talk about isosceles trapezoid. What does isosceles mean? We use it for triangles sometimes too. That's scaling. That's scaling. Isosceles is 2 sides are equal. So an isosceles trapezoid is going to have these 2 legs of the trapezoid are going to be the same. So if I took that and I rotated it around the long base, so I spun that around this way, which one of these shapes would it give me? What do you think? C. Right? Because in the middle is like a rectangle, right? And when you spin that around, it gives you this like cylinder part in the middle. And then the edges are going to be triangles. And when you spin a triangle around, it's going to give you a cone. So that would be C for that one. Okay? All right. The last thing that we're going to look at here before we do some practice with this is a net. So a net is like you could fold it up and it would make whatever shape you're looking at. Whenever I see these, I think of like when I buy cake boxes in the store to put cakes in. If I'm taking it somewhere where I don't want to have to use like my cake plate, or if it's too tall, then I will, they come flat, right? And you have to like fold them all up. So this is, we fold this side up and all these sides up, and then this is the flap that goes over the top. That would be the net of a cube. So let's match these. For this first net, which one of these is that going to be? It's going to be A. It is going to be a cylinder, right? You would just you would do what Isabella just did with her paper a little bit ago. You'd roll up the sides and flop the lids on either side, right? What about 2? Okay, it is C. Okay, now how do I know that is a square pyramid instead of a triangular prism? Those are kind of close. The square's in the middle, and all those sides are triangles, right? So in a pyramid, all your lateral sides are going to be triangles. So pyramids should have a bunch of triangles in them, right? But in a prism, what are your sides? Rectangles. So for number 3, that is your triangular prism. That is B, because all your sides are rectangles. You got the 2 opposite sides and then the rectangles in between. Okay? So we are going to do